Picture this. You're standing in Yellowstone National Park, surrounded by geysers spitting steam, colorful hot springs bubbling away, and the faint, earthy scent of sulfur in the air. Beneath your feet, the ground feels solid, but it's alive, rumbling, shifting, whispering secrets about a power so immense it could reshape the continent. Yellowstone's seismic swarms, those clusters of small earthquakes that ripple through the park, have been making headlines lately. They have got people asking big questions. Are these tremors just the park-as usual grumbling, or are they hinting at something bigger? Let's dive into what these swarms really mean, not just for Yellowstone, but for all of us. If you've ever read a clickbait headline about Yellowstone's supervolcano, you might think the ground is about to explode any second. Spoiler alert, it's not. Seismic swarms, clusters of earthquakes, often small, happening in a short time frame, are a normal part of Yellowstone's geologic personality. Think of them as the park's heartbeat, irregular but steady, a sign that the earth beneath is alive and kicking. These swarms aren't new. They've been happening for millennia, long before we had seismometers to track them. Here's the deal. Yellowstone sits on top of a massive volcanic system, one of the largest in the world. The park's famous geysers, hot springs, and mud pots are all powered by a giant magma chamber deep underground. This chamber, a roiling mass of molten rock, is what makes Yellowstone a supervolcano. Unlike your typical cone-shaped volcano, think Mount St. Helens, Yellowstone's caldera is a sprawling, bowl-like depression, about 30 by 45 miles wide. That's big enough to swallow entire cities. The swarms we feel today are often tied to the movement of magma, hydrothermal fluids, or gases in this system. But, and this is key, they don't automatically mean an eruption is coming. The misconception that every tremor signals doom comes from our love of dramatic stories. Movies and sensational headlines don't help, painting Yellowstone as a ticking time bomb. In reality, swarms are like the park clearing its throat. For example, in 2017, a swarm near West Yellowstone produced over 2,400 quakes in 3 months, with the largest hitting magnitude 4.4. Scary? Maybe if you felt it. Catastrophic? Not even close. Scientists at the Yellowstone Volcano Observatory, YVO, who monitor this stuff 24/7, say swarms like these are business as usual. They're caused by faults slipping, fluids moving, or the crust stretching as magma shifts far below. Most quakes are so small, below magnitude 2, you'd need sensitive equipment to even notice them. To grasp why Yellowstone is such a big deal, let's zoom out and compare it to a normal volcano. Picture a classic volcano like Vesuvius in Italy, a steep, conical mountain with a clear vent where lava spews out. Now erase that image and imagine a massive sunken crater so big you could drive across it for an hour and still not reach the other side. That's Yellowstone's caldera. It's not a single peak, but a vast hidden basin formed by ancient eruptions that collapsed the ground above. The caldera's size is mind-boggling. It covers an area roughly the size of Rhode Island. Beneath it lies a magma chamber estimated to hold enough molten rock to fill the Grand Canyon several times over. This isn't just a volcano, it's a supervolcano, a term reserved for systems capable of eruptions so massive they could alter global climate. The last major eruption, about 640,000 years ago, spewed 240 cubic miles of ash and rock, blanketing much of North America. For context, the 1980 Mount St. Helens eruption released about 0.25 cubic miles of material. Yellowstone's past blasts were 1,000 times larger. But here's the kicker. Those cataclysmic eruptions are rare. Yellowstone has had 3 in the last 2.1 million years, and smaller lava flows have happened more recently, about 70,000 years ago. The swarms we see today aren't tied to those mega eruptions. They're more like the creaks and groans of a massive geologic engine idling. The YVO uses a network of seismometers, GPS stations, and satellite data to track these movements, and their data shows no signs of an imminent eruption. The ground rises and falls a few centimeters each year as magma and gases shift, but it's been doing that for decades without blowing its top. What makes Yellowstone a supervolcano isn't just its size, but its potential impact. A full-scale eruption would be a global event. Ash could blanket the U.S., disrupting agriculture and air travel. Sulfur aerosols in the atmosphere might cool the planet for years, like a mini ice age. But let us be clear. The odds of this happening in our lifetime, or even the next 1,000 years, are vanishingly small. So why do the swarms matter? They're a window into what's happening deep underground. Each quake is a clue, a tiny piece of a puzzle scientists are piecing together. For instance, swarms often cluster along faults or near areas where hydrothermal fluids, like superheated water and gas, move through the crust. In 2023, a swarm of over 1,000 quakes hit near Norris Geyser Basin, one of the park's hottest and most active geothermal areas. Researchers found that many of these quakes were linked to fluid movement, not magma rising to the surface. This matters because it helps us understand how Yellowstone's plumbing works, how magma, water, and gas interact to create the park's iconic features. As of September 2025, Yellowstone's seismic activity is within normal ranges. The YVO reports several small swarms each year, with recent ones in the Maple Creek area and near Old Faithful. Most quakes are below magnitude 3, felt only by instruments. The ground continues its slow dance of uplift and subsidence, driven by magma chamber dynamics. GPS data shows the caldera rising about 2 to 3 centimeters per year in some spots, consistent with long-term trends. Nothing suggests a dramatic change is brewing. But let us talk about what keeps people up at night. Could a swarm ever signal the big one? Scientists say it's possible but unlikely without clear warning signs. Before a major eruption, we'd expect bigger quakes, magnitude 5 or higher, rapid ground deformation, think meters, not centimeters, and unusual gas emissions. These signals would build over weeks or months, not days. The YVO's monitoring network is designed to catch these red flags early, giving us time to prepare. Let's say a swarm does escalate, not to a super eruption, but to something more immediate, like a hydrothermal explosion. These are smaller but still dangerous events where pressurized water and steam blast through the surface, creating craters. One such explosion in 1989 at Porkchop Geyser sent rocks flying and left a 10-foot wide hole. If a similar event happened near a crowded boardwalk, it could injure people or damage infrastructure. The park's geothermal areas are closely monitored for this reason, and some trails close temporarily during intense swarm activity. For the surrounding region, Wyoming, Montana, Idaho, swarms are a reminder to stay prepared. A rare, larger quake, say magnitude 6 or 7, could shake buildings, trigger landslides, or disrupt roads. The 1959 Hebgen Lake earthquake, a magnitude 7.3 event just outside Yellowstone, killed 28 people and caused massive damage. While not directly tied to the supervolcano, it shows what the region's active faults can do. Local communities have emergency plans, and the park itself is built to withstand moderate quakes. Globally, Yellowstone swarms are a call to keep studying supervolcanoes. What we learn here applies to other hotspots, like Toba in Indonesia or Campifligre in Italy. Better monitoring tech, seismic imaging, gas sensors, satellite radar, helps us predict volcanic behavior worldwide. It's not just about Yellowstone, it's about understanding how our planet works. You might be thinking, okay, cool, but I don't live near Yellowstone, why should I care? Fair question. The swarms remind us that our planet is dynamic, always changing in ways we can't fully control. Yellowstone's supervolcano is a humbling force, a reminder of nature's power and our need to respect it. Even if an eruption is unlikely, the park's activity shapes how we prepare for natural hazards everywhere. Earthquakes, tsunamis, eruptions, you name it. Plus, Yellowstone is a treasure. Its geysers, wildlife, and raw beauty draw millions of visitors each year. The swarms are part of what makes it so alive, so unique, They're a signal that the Earth is still sculpting this place, just as it has for millions of years. By studying these quakes, we're not just guarding against disaster. We're learning how to coexist with a living planet. So, what's next? The swarms will keep coming as they always have. Scientists will keep watching, piecing together the story of Yellowstone's restless heart. New tech, like machine learning to analyze seismic data, is helping us get better at spotting patterns. Maybe one day we'll predict volcanic activity the way we forecast weather. For now, the YVO's message is clear. Yellowstone is active, but it's not about to blow. Next time you hear about a swarm, don't panic. Think of it as Yellowstone whispering, "I'm still here." It's a chance to marvel at the forces beneath our feet and appreciate the science keeping us safe. Whether you're hiking in the park or reading about it from halfway across the world, those tremors connect us to something bigger. A planet that's always moving, always alive.